Hi everyone. The goal of this video is to be able to justify properties of different shapes using slope calculations. By the end of this video, you should understand what that means, and we'll refer back to that. So I have two pictures here of different kinds of lines, and I just want to start by making some observations about these lines. Then we can go back with the math that matches. So if you look at these two lines, what do you notice about the relationship between them versus these two lines? So first thing I see is that these lines cross at a point and these lines don't cross at any points. So the first thing you might notice is, well, these never cross. And what do we call lines that never cross? We call those parallel lines. Okay, so very first thing you should notice that these lines are parallel. And we can go back and figure out, what makes lines parallel on a coordinate plane. Whereas these lines, they definitely intersect at a point, so we'll say at least they intersect. But if you look more carefully at how they intersect, it kind of looks that they intersect at a right angle. Now, we can't necessarily assume that, but our goal in this video is to be able to prove that. So maybe they intersect at a right angle. Or you can say that in a few different ways. You can say they're 90 degree, they meet at 90 degrees, or the more precise word that's kind of like parallel for these lines is perpendicular. These are perpendicular lines. Now, for the sake of our investigation, I'm going to tell you these lines are perpendicular. So we're going to figure out, what about the slope makes these lines parallel or perpendicular? I think the easier one to start with is actually parallel. So we're going to start there and go backwards. Okay, now that we have an idea that these are parallel, I want us to work with the numbers and see what makes parallel lines. So that means we're going to calculate the slope of each line. So I'm going to call this line 1. I'll call this line 2. We'll go ahead and calculate slope and just kind of refresh that here. So just a reminder, our slope is our rise, which is like going up, down, over our run. And it's really the change in the rise and the change in the run. I don't know why I drew the same arrow, but rise is going up, down, run is going left, right. And I always think about stairs. So when you walk upstairs, first you have to step up, which is our rise. And then you kind of like walk over the stairs, which is left, right, which is our run. Okay, and on a graph, you can just count between any 2 points what the rise and the run are. So let's say I pick this point here, because that's a nice, easy point. Our x-coordinate is not moving left or right at all, so x would be 0. But our y, and I should say that this is the x-axis, is horizontal axis, and the y-axis is vertical. So I'm not moving at all on the horizontal axis from 0, 0, but I am moving up 1. So our y-coordinate's 1. Now, in order to calculate the slope, you need to know how much the x and the y are changing between 2 points on the line. So maybe I'll pick this one, and I'll pick one more that's like on one of these like nice little t's, so I can count really easily. In this point, you're moving 2 on the x direction, and you're moving up 2 on the y direction. So it's 2, 2. Now, if I want to calculate the slope, I need to know how much we're rising from one point to the other and how much we're running. So we get from one point to the other, we have to rise 1, and we have to run 2. So our slope of this one is 1/2. Okay, I want you to repeat the process with line number 2, calculate the slope, and I'll come back with the answer. Pause the video. Okay, now I'm not going to reveal the answer. I hope you did this on your own. I just kind of labeled the 2 points that I wanted to use. I calculate how much I'm rising and how much I'm running. Slope is rise over run. So we're rising 1, running 2. Our slope is again 1/2. And I just want to point out, if you use 2 other points, you should get the same thing. So just to kind of double check that, let's say I use this point and I use this point because I wasn't, seeing this point here. I'm rising 1, 2, and I'm running 1, 2, 3, 4. Okay, so it's 2 or 4, but what does that reduce to? You can divide these both by 2. And then you get that it's still 1/2. So it doesn't matter which points you pick. So now we know that these lines are parallel, and what do you notice about their slopes? Their slopes are exactly the same. And why does this make sense? Well, it makes sense because if your slopes are going in the same direction, at the same speed, they'll never touch. So if one was slightly, turned, then they might intersect. And once you turn this, it became steeper and the slope was different. But both of these lines are going at what I call like the same pace. They're at the same rate of change. Now they're starting at different places, but if they're going at the same speed or at the same rate of change, they're never going to catch up. It's kind of like if I were walking and you started like 10 feet behind me and we were walking at the exact same pace, you would never catch up to me because I started ahead of you. That's what these lines are doing. They start at different places, but they're going at the same place, so they'll never touch. And so to kind of fill in the key concept here, what you want to know is that all parallel lines have the same exact slope. So if two lines are parallel, they will have the same slope. So for example, if you had equation of a line is y equals mx plus b, wow, this is a lot of review here, and it was negative 3x plus 1, and then you had y equals negative 3x minus 10, these would be parallel because their slopes are both negative 3. Okay, now these are perpendicular lines, and as you can tell, the slopes are pointing different ways. Like this one's pointing up, which means this slope is positive. Okay, and this one's pointing to the left, so it's pointing towards the negative numbers. Let me backtrack on that for a second. This is pointing towards the positive numbers. So if you read it like a book from left to the right, it's getting more positive as you go on the x. Whereas if you read this one like a book, well, or just kind of follow up the line, it's pointing towards the negative numbers and keep getting more negative. So this one has a negative slope. Now let's actually go ahead and calculate the slopes of both of these to see what the relationship is. Again, I want you to calculate the slope on your own, and I'll come back to make the comparison. Okay, I hope you did this on your own. It's good practice. I'm going to quickly recap. So line 1 called this purple line here, where I did purple. I picked these 2 points. You could have picked 2 others and got the exact same thing. Then I just counted. I have to rise 2 and run 3. So that means the slope of line 1 would be 2/3. Okay, whereas the other line, I picked this point and this point, and I'm going to have to rise 3, but run 2. But notice when I run 2, I'm going this way for a change, which means I'm getting more negative. So it's kind of like you're subtracting 2. So I'm rising 3 and running negative 2. So the slope of this one is actually negative 3/2. Or another way you could have said it is, okay, let me just count positive. I'm rising 3, running 2, but I know this line has a negative slope because it points in the negative direction. So you could have just said 3/2 and then thrown on the negative at the end. But either way, that's got to be a negative slope, whereas this one's a positive. So what do you think the relationship is between these two? They're for sure not exactly the same, but I notice one's positive and one's negative. This is positive, this is negative, and they have the same numbers. This one is 2 on top, this one is 2 on bottom, 3 on top, 3 on bottom. Okay, so we're talking about perpendicular lines here. What's the relationship? So perpendicular lines have slopes that are, normal please. Number 1, they're opposites. Okay, one has to be positive and one has to be negative. So when I say opposites, you can say opposite signs if you prefer. Be more specific. One's positive, one's negative. Okay, and they are reciprocals. That's a big math word there. Reciprocals. Reciprocal means that they're flipped. So if I took this and I switched them around, I would have this slope. So examples of opposite reciprocals would be, and I'm not going to write the equation line, I'm just going to write m because m represents slope. So if one of our slopes was 1/3, the perpendicular slope would be opposite reciprocal. So it'd have to be negative since that's positive, and it'd have to flip. So if this is 1/3, this would be 3/1. Okay, or another example, if you had m equals negative 4/5, the perpendicular slope would be m equals positive 5/4. So how does this apply to our geometry? Okay, what you're basically going to be doing is looking at shapes and proving that they're the shape you think it is using slope. So let me give you an example. Okay, if I'm looking at this quadrilateral here, I know it has 4 sides. It kind of looks like a rectangle because I think these are the same. I think these are the same. These look like 90-degree angles to me. Okay, so what I'm going to write about observations is I think it's a rectangle. It looks like there are 4 right angles. Okay, looks like opposite sides are congruent. Now, it's not enough, as we've learned, to, say it. You have to prove it with math. So the one thing we know how to prove is how do I know if these lines make a right angle, which is what I've talked about up here. Right angle means perpendicular. So essentially what you need to do is prove these 2 lines meet at a 90-degree angle. And how do you do that? Well, I know any two lines that meet in a right angle have perpendicular slopes. Okay, so I want to show that the slopes are perpendicular. If the slopes are perpendicular, you know those lines meet at a right angle, so those angles would be 90 degrees, which means it would be a rectangle. Now, in terms of congruency, we haven't talked about finding distances on the coordinate plane yet. You will learn this in a future video. But basically, it's enough to show that all the angles are right angles to prove that this is a rectangle. Okay, so I'm looking at this line, specifically, and this line. Now, you could pick two other lines. I just picked two because I felt like it. In order to determine that these meet at a right angle, you need to know the slope between these two lines. So I need to know, is AB, which is the side length, which is also a line, is that perpendicular to AD? Remember, this line means perpendicular. Okay. In order to do that, I need to find the slope of each of those. Okay. In order to find the slope of AB, there's a couple ways you can do it. You can continue our counting, or I'm going to remind you of the slope formula. So to find the slope, you're going to calculate the change in y's. I'm going to abbreviate change by CHNG in the y coordinate over the change in the x, which is basically what you did before, but you counted the change. Now I'm just going to calculate it. So to calculate the change in the y's, you're going to take the y coordinates and subtract them. And change in x, you'll take the x coordinates and subtract them. So let's just keep that consistent here. So if this is my change in y's, I'm going to look at my two y coordinates. So I'll do 2 minus 0. Basically what I've done is I've called this my y2 and this my y1. So if this is y2, that means this has to be x2 and x1. I just got to keep it consistent. So I'll do 3 minus negative 3. Ooh, and when you subtract a negative, what actually happens there? It's going to become positive. So 2 minus 0 is 2. 3 minus negative 3 is actually 3 plus 3, which is 6. You can divide both by 2. And this is actually 1/3. Now, in order to prove those are perpendicular, you need to show that AD has the opposite reciprocal slope. So I'm going to pause the video. What I want you to do is calculate the slope of AD. No cheating and peeking. I want you to practice on your own. Okay, before I reveal the answer, I want to say one thing. If you're struggling with this, what's easier about these problems is that you just saw lines. So sometimes what I do is I take my highlighter and make this look more like a line. I focus just on that, and then I calculate my slope. So here are my two y coordinates. I'll call this y2 and y1. Here are my two x coordinates in blue. I'll call it x2, x1. So subtract your y's is 0 minus negative 3. That's your change in your y. Your change in your x would be negative 3 minus negative 2, which I've written out here. Okay, so y2 minus y1 is 0 minus negative 3, but when you subtract a negative, it's actually positive. And then it'd be negative 3 minus negative 2, but again, when you subtract a negative, it becomes positive. So it's 3 over negative 3 plus 2 is negative 1. So what do you notice about these slopes? First of all, one's positive, one negative. Second of all, they're reciprocals. So I've proven that these slopes are opposite reciprocals, which means I can say with all certainty and mathematical proof that AB is perpendicular AD. And you could go ahead and repeat this for all those, but that's enough to say right now that this is a rectangle, like I thought it was. So therefore, you can use Algebra 1 and slope to prove things about coordinate geometry or geometry on a coordinate plane. Okay, I'm leaving one for you to try. I want you to think about what kind of triangle you think this is. Okay, and can you prove it by calculating slopes? So go through the same kind of process I did, and I'll have more for you to try when I've checked this in with you. If you have any questions, please pause, stop, take a step back, rewatch, or raise your hand and ask me. Have a great day.